Welcome. We're going to go over the properties of exponents, and I have 80 examples, 90 if I'm up to it, but there's definitely enough here for you to figure this out. I'll put timestamps so you can jump around to the different properties. But good, the very first property we're going to start with is the zeroth power. The zeroth power. Let's pull that up right here. I got all these ready to go. Boom. Zeroth power. So the zeroth power says that anything to the zeroth power will be 1. And you could think of this A right here as standing for anything. A for anything. Anything to the zeroth power is going to be 1. So let's start here with our first example. We have a negative 7 to the zeroth power. Because it's in parentheses, everything in the parentheses is getting hit by that exponent. So this right here equals 1. That's it. Don't overthink it. Anything to the zeroth power is 1. But here, in the next example, we're going to remove the parentheses. So a way you could think about this is this negative out front is a functioning negative 1. So we could rewrite this as negative 1 times 7 to the zeroth power. And 7 to the zeroth power right there, that's going to be your 1, right? That's your thing to the first power. That's going to give you your 1. So that right there is a 1, and negative 1 times 1 is negative 1. So you may have seen that from the beginning, but that's the difference between this example and the last right here is if it's in parentheses, it will be positive 1 because the negative will go away. However, if there's no parentheses, that negative makes the final answer negative. But good, how about this right here? We have 100 ABC, everything in parentheses here to the zeroth power. Since everything is inside, it gets hit with that zeroth power. The answer here is 1. It didn't matter if it was 100, 1,000, a million, a billion, right? If it's to the zeroth power, 1. That's the zeroth power right there. All right, good. And then right here we have pi to the 0 minus e to the 0. So, well, pi to the 0 is 1, e to the 0 is 1, and 1 minus 1 is 0. So the answer there is 0, and that's it right there. So that is the zeroth power. Good. Next, we're going to do the product of powers. The product of powers. So let's switch that. Boom, boom. There we go. Okay, the product of powers, what does it say? If you're multiplying two exponential expressions with the same base, notice that they both have an A. It's not an A and a B or an X and a Y. It's two A's. Then you can add the exponents, and all you have to do is add the exponents. So what does that look like? Well, if I have something like 2 to the third times 2 squared, well, just add the exponents. Add the 3 and the 2. 3 plus 2 is 5. Now, 2 to the 5th power, you could figure that out, right? 2 times 2 times 2 times 2 times 2, right? 5 times. That is going to get you to 32. So the answer there is 32. All right, good. Now, let's go to the next one here. Let's see what we got here. So, boom. Add the exponents. The 8 plus 11. What is 8 plus 11? 8 plus 11 is 19. Good. And you don't have to figure out what 7 to the 19th is. The last problem we could figure out 2 to the 5th. That's not too bad. But this, you just leave it. Just leave it like this. 7 to the 19th. That is fine. Here we go. Same thing, even if we're dealing with variables. There we go. I only want to see one problem at a time. So add this, 12 plus 5, 12 plus 5, and that equals, what's 12 plus 5? 12 plus 5 is 17, so the answer here is x to the 17th power. That's it right there. That's all you got to do. That's all you can do. Don't overthink it. Good. All right, here's a good one. When you don't see an exponent on one of the variables, the implied exponent is 1. So this is a y to the first power here. Then we add the exponents, so we have 6 plus 1 now, and that is y to the 7th. The answer is y to the 7th power, just like that, just like that. Good, good. All right. Here we go. All right, now we're getting a mixture of variables, more than one variable here. Do your A's with your A's and your B's with your B's. So I can add the 2 and the 4 on the A's, and then I'm going to add the 3 and the 5 on the B. So this gives me A to the 6th power, B to the 8th power, and that's it right there. That's your answer right there. All right, let's get some numbers involved. We have a 2 and a 3. So as far as the 2 and the 3 are concerned, this is what I noticed some people will confuse is we're going to multiply the 2 and the 3, but we're adding the exponents. So there is multiplication here, but there's also addition. Also this x, y we have out front, that's an x to the first and a y to the first. So each of those have an exponent of 1. Good. Multiply the 2 and the 3. 2 times 3 is 6. Add the exponents. We have 1 plus 2 for the x, and we have 1 plus 3 for the y. So this is 6x to the third power, y to the fourth power. Just like that, right there. Just like that. Good. That's good. All right. All right, getting a little bit bigger. So, yeah, we have 3 variables now, but just put your a's with your a's, your b's with your b's, and your c's with your c's. Good. This is a b to the first power. This is a to the first power. That's a c to the first power right there. So watch out for those ones. -5 times 7. Again, realize that all of this is just one big chunk of multiplication, meaning order doesn't matter, right? Multiplication is commutative. So I could just right away multiply the -5 by the 7, and that is -35. Now for my A's, I have a 3 and a 1 that need to be added. For my B's, I have a 1 and a 6. And for my C's, I have a 2 and a 1. So the answer here is -35. A to the fourth, b to the seventh, c to the third, or c cubed. And that right there is the answer. Good. That's it. And again, we're just being unreasonably large here, but just to stress the point that even though this problem looks long and complicated, it is not. This p and q right there, those have exponents of 1, and then just add up all your p's. On the p's, on your p's, we have a 14, we have a 9, we have a 1, we have a 0, which isn't really going to change anything. And then on the q's, we have a 2, a 13, a 1, and a 0. So you're just adding all those up. All right, what is that? What is 14 plus 9 plus 1 plus 0? That's 24. And then on the q's, we have 2 plus 13. That's 15 plus 1 is 16. That's your answer right there. That's your answer right there. Combine your p's with your p's, your q's with your q's. That's all you got to do. And that's it right there. That's it. So good. Good. All right. This works the same way, even if you have negative exponents. Now, later we're going to learn another thing you could do with negative exponents, but for now, we're using specifically the product of powers property, which you can see here. Oh, if I point below like that, oh, that's cool. It's right there below me. So here, we're just adding the exponents. So this would literally be 10 plus -7. However, adding a negative number is no different than subtracting. That's what it means. That's 10 minus 7, which here, the answer is x to the third power, or x cubed, right? Third power is called cubed, second power is called squared. Those are other words for that. All right, good. Same thing here, same thing here. This would be z to the -2 plus 6, and -2 plus 6 is 4. Answer there is 4, z to the fourth. There's z to the fourth. All right, here we got three variables. Or no, we have one variable, but 3 terms. This is going to be a to the -3rd plus 8 plus -1. Right, because we are using product of powers here, so we're technically adding. However, well, let's do -3 plus 8 first. -3 plus 8 is 5, and then plus -1 is the same thing as -1, so this becomes a to the fourth. It's a to the fourth right there. Okay, hopefully by now you've caught on that adding a negative number is the same thing as subtracting. So right here, I'm just going to go 15 minus 4 minus 3. That's what that means. 15 minus 4 is 11. Minus 3 is 8. This is d to the 8th power. That's it. Good. So even though you haven't learned the particular properties for negative exponents, you can still apply the product of powers by adding them. That's fine. And good, let's see, that's all of them. Can we see all this on the screen at once? Just about. Oh, look at that. That's beautiful. There you go. There's all the problems right there. A little faded around the edges, but you can make it out. So that's product of powers. All right. Next property. What's the next property? Power of a power. So we're going to do next. Power of a power. So let's switch that. Here we go. Now we're doing power of a power. Looks great. Looks great. the amount of work that goes into just getting this video ready. But okay, we're moving. So power of a power here is that when you have an exponent and an exponent, or a power to a power, you multiply the exponents. So mn right there, that means m times n. And then, yeah, good. Okay, so let's do it. Let's see some examples here. So first one, we have 2 to the third to the fifth. So that's a power to a power. Multiply the exponents. 3 times 5 is 15. And no, you don't have to figure out what 2 to the 15th is, right? That's a little too much. You just leave your answer like that. That's fine right there, just like that. All right, it's the same thing even when you're dealing with variables. So here, all you got to do is multiply the 6 by the 4. 6 by the 4 gives you x to the 24th power. That's it. That's it right there. Same thing, even if you have negative exponents, it's the same. Now be careful, this is not negative 2 minus 13. Because of the parentheses, it's a power to a power. So right here, it is b to the negative 2 times negative 13. And a negative times a negative is a positive. 2 times 13 is 26. This turns into a positive 26 right there. Okay. So this 7 here is just meant to mess with you. Notice how the 7 is not in the parentheses, which means the exponents in the 7 are not connected at all, right? The 7's just going along for the ride, and then we multiply the exponents. That's negative 4 times negative 9. Negative 4 times negative 9 is positive 36. And again, the 7 really didn't do anything there. It just tagged along. All right, here we go. Same thing, this negative 2 is not going to do anything. Negative 2, and just multiply the exponents. Negative 10 times negative 11. Negative 10 times negative 11 is positive 110. Multiply the exponents. 0 times 8. Well, 0 times 8, that's still 0. And then if you remember, right, remember previously? Look below me right here. Let's bring back the 0th power. Boom, look at that. What is the 0th power? So this is literally that right there. Oh, I'm pointing up, but it's below me. That's fun. That's weird. Okay. What is this? That's 1. That's 1. Remember the 0th power? Anything to the 0th power is 1. All right. Here we go. And let's bring back the power of a power. That's what we're doing right here. Okay. The y minus z right here, that's binomial. That's just meant to mess with you. All you're doing here is multiplying the exponents. You're multiplying the exponents. You don't have to do anything else. Leave the y minus z like it is. Multiply 7 times 8. What is 7 times 8? That is 56. Now, I'm going to throw something else in here while we're here. I see people all the time, students all the time, they really want to take this a step further and write it as y to the 56 minus z to the 56, right? They feel like they want to distribute the exponent. It doesn't work like that. In fact, this purple is false. That is a false statement. So that is not how this works. You will end up with wrong answers and false statements if you try to do that. So what I have highlighted is the answer. Good, same thing here. I will write out an intermediate step. So this would be p plus q. You're not actually doing anything with the p plus q. You just need to multiply negative 1 by negative r. Well, what is negative 1 times negative r? It would be positive r. And that's it. That's all you can do there. Word of caution, again, this is not the same thing as p to the r plus q to the r. Don't do that. That is incorrect. You will end up with the wrong answers if you try stuff like that. Okay, that looks like that's the end of power of a power. Let's see. I want you to be able to see this whole thing if I zoom out a little bit. There we go. That's nice. Oh, okay. There you go. That's all of them if you want to take a screenshot or something. Very nice. All right, next thing we have is power of a product. Power of a product. So what does that look like? Let's go right there. There it is. This is your distributive property of exponents, right? Not what I wrote in purple before, but here in a sense, you're going to distribute the exponent on the outside to both terms on the inside, which is why you get a to the m and b to the m if you want to get rid of the parentheses. So, real quick, a word about the names of these things. Power of a product. Okay, what does product mean? Like if I add two things, I get their sum. If I subtract two things, I get their difference. If I multiply two things, I get their product, right? Product is the word for multiplication. AB, that means A times B. So this little thing that I've highlighted, that's a product. And then we have a power of that thing. So that's why this is called power of a product, right? These things are named for what they are. Anyways, you're like, dude, just get to the point. So how do we do this? All right, I have a 3 and an x in parentheses. Both of those things need to be squared. I see a lot of students forget the numbers, right? They just do, this is what I see people do. They write 3x squared like that. It is incorrect. You need to also square the 3. Square everything. And what is 3 squared? 3 times 3 is 9. So this is actually 9x squared. That would be the correct answer. Same idea here. You need to do 2 to the 4th power and y to the 4th power. 2 to the 4th power, that's 2 times 2 times 2 times 2, 4 times. That is going to give you 16. Okay. So here, this is where you want to start differentiating between what's in the parentheses and what's not. So because the 5 is outside the parentheses, it has nothing to do with the exponent of 7. You only need to apply the 7 to the a and the b, not the 5 this time. 5 is on the outside of the parentheses. If the 5 were on the inside of the parentheses, we would have done 5 to the 7th power as well. That's it, one step. That negative, where's the negative? The negative is on the outside of the parentheses. So it just tags along. We need to apply the exponent of 2r to the p and to the q. Again, don't overthink this. You're not bad at math. You just overthink things. This is all you have to do here. All right, let's bump it up a little bit. So this is going to combine, let's see. This is going to combine the power of a power property. So this is the last one we did where you have to multiply the exponents with this power of a product property where you have to distribute the exponents. So in a sense here, yes, you are going to distribute the 5 to those exponents and you're going to multiply them. So this is going to give you, I'll write out, I'll be detailed for now. This is going to be y to the 2 times 5 and z to the 3 times 5. 2 times 5 is 10. 3 times 5 is 15. That's it right there. That's it right there. Even if the exponents are negative, same rules apply. Distribute, distribute. So this is going to be c to the negative 1 times negative 3. D to the negative 2 times negative 3. And this problem was designed so that the negatives go away. Negative times a negative is a positive. So we have c to the positive 3. Negative 2 times negative 3, that is positive 6 right there. The negative 5 is on the outside of the parentheses. So nothing happens to it yet. We need to cube the 2. And we need to multiply the 7 by the 3. So that right there, that's your distribution right there. 2 to the 3rd power, 2 times 2 times 2 is 8. And then on the exponent right here, 7 times 3 is 21. Now make use of the negative 5. We have a negative 5 times 8 right there. That is negative 40 t to the 21. There we go. That's our longest problem so far. That was a good one. That was a good one. All right. This is meant to, again, throw you off. All you're doing here is multiplying the exponents. That's all you got to do. That's all you got to do right there. I like my arcs to be nice. All right, we'll live with that. So that's going to be x to the negative 4 times a. Leave the y plus z alone. It's like a package deal. We're not going to mess with it. We're just going to multiply. Ooh, I made a mistake. We needed this to be a negative a. It is a negative a. There we go. And then on the y plus z, we have negative 9 times negative a. So all you're doing here, negative 4 times negative a. Negative times a negative is a positive. 4 times a is just 4a. And then y plus z, negative 9 times negative a is positive 9a. And that is the answer. And that concludes that box right there. What is next? Quotient of powers. Quotient of powers. Here we go. Quotient of powers. Whenever you're dividing exponential expressions with the same base, you subtract the exponents. And again, this only works if these match. See how I have two a's here? If that's an a and a b or an x and a y, you cannot subtract the exponents. You can only do your a's with your a's, your b's with your b's, your x's with your x's, right? So be careful with that. But here's some examples. If I'm trying to simplify this right here, yes, you don't actually have to figure out what 5 to the 7th power is. Don't figure out what 5 to the 5th power is. Subtract the exponents, 7 minus 5, and that is 2. And 5 to the 2nd power, or 5 squared, let's see, I want better penmanship. 5 squared, 5 times 5 is 25. It does the same thing. It's the same thing even with variables. So subtract the 14 minus 8. 14 minus 8 is 6. Minus 8 is 6. All right. Your A's with your A's, your B's with your B's. So the 5 is just going along for the ride. For the A, we have 20 up top, minus 2 on the bottom. For the B, we have 13 up top, minus 7 on the bottom. 20 minus 2 is 18, and 13 minus 7 is 6. The m plus n is a package deal, meaning it could have just been an x and an x, but we have an m plus n. This negative is just going to tag along. Don't mess with the m plus n. Just copy it down. All you're doing here is the exponent. 34 up top minus 21 on the bottom. Everything else just copies the same. 34 minus 21 is 13. That's it. Don't do m to the 13 plus n to the 13, right? You cannot distribute an exponent over addition. You can only distribute an exponent over multiplication. Same thing, even if one of them's negative. And this is what I want you to see is, again, you're going to learn different ways to handle negative exponents, but I do want to show you that the other properties, like the quotient of powers or product of powers, they still work, even if one or multiple of your exponents are negative. So careful though here. You want to go 3 up top minus negative 2 on the bottom. You have a double negative. You have the minus from the property, which is right below me, and you have a negative because this 2 is negative. Due to this double negative, you now have 3 plus 2, which is 5. Here's one with a 0. And right. Maybe you're thinking p to the 0th power, that is 1, and that's correct. But I want you to actually do the subtraction here with the 0. So this would be 0 up top minus negative 15 in the bottom. 0 minus negative 15 is 0 plus 15, and 0 plus 15 is 15. So that's how you would do that if you didn't know about the whole 0 exponent equaling 1. and you didn't know else to deal with negative exponents. That's how you could get that done with just the quotient of powers property. All right, we have multiple variables, multiple negatives. So again, I'm just trying to help you with the negatives. So we have a -1 up top minus -3 on the bottom for the C. For the D, we have a -2 up top minus a -4 in the bottom. So we have as many negatives as possible. The -1 will stay a -1, but the minus -3 becomes a +3. On the D, the -2 will stay a -2, but the minus -4 becomes +4. -3 plus 1 on the C right here. -3 plus 1, what is that? That is 2. And on the D, we have -2 plus 4. -2 plus 4 is also 2. And that would be your answer right there. -1 minus 3, Yep, I agree. All right, here we go. Back to only one variable, just K, but multiple. We have three Ks. So I should probably change that problem. But here we go. Let's just do the math. This would be 27, just goes along for the ride. And we would have 10 up top, minus -3 on the bottom, minus -5 on the bottom as well. So, oh, here we go. I'm going a little off screen. There it is. And this would equal 27. So all these double negatives would turn to positives. 10 plus 3 plus 5. And then what is that? 10 plus 3, 13, plus 5, 18 is the answer right there. There you go. I'm going to get canceled for that problem. But hey, I hope you learned something. Do we have more of these? Nope. That concludes the quotient of powers box. Let's see. Let's zoom out a little bit. There's all of them right there. There's all of them right there. Quotient of powers. So yes, even though there were negative exponents in that in some of these problems, it didn't matter that you don't yet know how to do negative exponents. It worked out with just the quotient of powers property. Okay, so I have this box right here labeled Practice 1, and it says simplify the following using the properties learned thus far. Meaning, these can be done with, with what you've learned. You have the zeroth power, you have product of powers, you have power product, quotient of powers. You have five of them. So let's see here. The first thing I might do is, why don't we apply the, and I'm going to do this slow. If you want to just skip until you see the answer highlighted, that's fine, but I am going to take my time on these. Product of powers right here. I'm going to apply this property first. So what does that look like? That means in the numerator, I would have 3x to the 7 plus 1, and in the denominator, I would have x to the -1 plus 3. I'm not dealing with the 2 on the outside yet. So 7 plus 1 is 8, and -1 plus 3 in the bottom, that is 2. Okay, good. So I applied the product of powers property first. Now, let's apply the quotient of powers property. So let's do this next. Notice how I'm simplifying what's inside the parentheses first. You don't have to do it this way, but it's one way. So now I subtract the exponents. On the inside, I subtract 8 minus 2. And what is 8 minus 2? 8 minus 2 is 6. All right, so I'm here now. And then what property is that? That is power of a product right there. So this is what I need to do now. I need to do power of a product. That would be 3 squared. X to the 6 times 2. 3 squared is 9. 6 times 2 is 12. That is it right there. We fit it all. We fit it all. That's very detailed. Now, did you have to go in that order? Not necessarily. You could have used the power of a product property first and distributed this 2 to everything right away. But it's usually nicer if you condense the inside of the parentheses first. Let's take a slightly different path on this one. The first thing I would do is use the quotient of powers property. Do your x's with your x's and your y's with your y's. So on the x's, I have, actually, how would you order this? This is how I would order this. -2 minus 6 for the x. For the y, I would have 0 minus 7 to the -3, right here like this. All right, subtracting those, -2 minus 6 on the x gives you x to the -8. 0 minus 7 on the y gives you -7 on the y. So here we are right now. All right, good. Don't worry. You're like, I don't know what to do about negative exponents. Well, you don't have to know that yet. Now just apply power of a product, which is your distribution rule for exponents. And that means I can multiply the -3 to the -7 and the -8. Ah, there you go. What? Negative times a negative. So I'll be detailed, but this is -8 times -3 on the x. On the y, you have -7 times -3. All right, -8 times -3 is positive 24, and -7 times -3 is positive 21. So that problem actually only used two properties. We started this problem with the quotient of powers, and then we finished the problem with the power of a product property. Let's start this off with product of powers. No, quotient of powers. Yeah, we're going to have to be subtracting. I mean, it's going to be a mixture of product and quotient of powers, but starting with the a's right here. So this would be 2 to the a. Quotient means I subtract the exponents. This is 2 minus -5. Watch out for that double negative. There's a q on the outside. We'll deal with that later. As far as the b's goes, okay, so right here, I'm going to combine product and quotient of powers. So I need to add the -5 and the 8 because those are being multiplied. But then you have the b to the -2 on the bottom. That's going to be a minus -2, and then all of this is squared. And this is all fitting on the screen. Good. All right, let's simplify all that. We're going to run out of space if I'm super detailed, so I need to do this 2 minus -5 in one step. That's 2 plus 5. 2 plus 5 is 7. How about all the b's? I need to do this right now at once. -5 plus 8 is 3, plus 2 is 5. Is that right? Let me think about that. Yes. So b to the 5th power squared. All right. And then to finish this problem, to get rid of those parentheses, we need power of a product. This is your distribution. Don't forget to cube the 2 as well. So this is 2 cubed, and then a to the 7 times 3, and then b to the 5 times 2. 2 cubed is 8. 7 times 3 is 21. 5 times 2 is 10. Okay. So just to recap, you learned the 0th power right there. Anything to the 0th power is 1. You learned product of powers, that if you're multiplying exponential expressions with the same base, you add the exponents. If you have a power to a power, you multiply the exponents. If you have a product to a power, you distribute the exponents. And if you're dividing exponential expressions with the same base, you subtract the exponent. So those are your basics, the fundamental properties there. Now let's move into the negative exponent. So here we go. The negative exponent has, I have 3 different versions here, but they're all meaning the same thing, that the negative exponent requires reciprocation. I can sit here and talk to you about it, but you're not gonna believe it until you start practicing it. So I'm just gonna highlight the first one right here. So I have the first one below, which is this box just duplicated, but let's put it to work. Okay. What I will add here is that there is technically a 1 in front of this 2. You could put a 1 times 2 to the -3rd power as a placeholder. And this becomes, actually, let's say what it's not first. I know what you're all thinking right now. 2 to the 3rd power is 8. So you really want 2 to the -3rd power to be -8, right? That's the temptation. But it's not. This is not true. It's not the negation, it's the reciprocation. You need to reciprocate. That's the proper word for flip. So flipping here would give you 1 over 2 to the third power, which is 1 over 8. So 2 to the negative third power is not negative 8. It's not the negation. It's 1 over 8. It's the reciprocation. Negative exponents reciprocate. Same thing for dealing with the variable. There is technically a 1 in front of this x, right? 1 is called the multiplicative identity. It is implied. It is behind the scenes, and we can use it if we need it. And this becomes 1 over x to the positive 7. Reciprocate and make your exponent positive. That's what that is. All right. So notice how in this problem we had a blue 1. We put a 1 in front because we needed to make use of it. This 1 stayed in the numerator. Here we don't have to do that because we actually have a number taking that front position. We have a negative 5. This negative 2 exponent and this negative 5 are not connected. They are not related. So when it comes to the reciprocation, you're going to leave the negative 5 up top and you're only going to move the 3 to the bottom and make it a positive 2. This is 3 to the positive second power now. And what is 3 squared? 3 times 3 is 9. The answer here is negative 5/9. That's how that works. That is how that works. Here, like, notice the difference. This negative 5, there weren't parentheses around the negative 5 and the 3. But here we do. We have parentheses around the negative 8 and the y, which means both of these need to be reciprocated. This is where we're going to use our 1. There is an implied 1 out front. That'll go in the numerator. And we will have negative 8y in the bottom now to the positive 4. So the difference here is that the negative 4 became a positive 4. The negative 8 stays a negative 8 because negative 8 was not the exponent. We're changing the exponent here. And then if we were to take this further, actually, let's not. This is the point I'm trying to make right now is the negative exponent. That's fine. That's all you got to do right now. All right, let's keep going. We have an a and a b that both have a negative exponent. You can't add these exponents, right? Don't try to do negative 2 plus negative 11 because a and b are different. It has to have the same base to apply the other properties. We're going to use the implied 1 out front. Because both of these have negative exponents, they both need to reciprocate. So this is 1 over a to the positive 2 times b to the positive 11. All right, notice the difference here. What's the difference here? The exponent on the a is positive, meaning don't mess with the a. Leave it up top. Leave it. It's already positive. It's the b that has a negative exponent and thus needs to reciprocate or go to the bottom. What you're going to notice is if a term has a negative exponent and it's in the numerator, it needs to reciprocate to the denominator and vice versa. We'll get to the other way around. But it's just flipping. It's flipping. Again, it's called reciprocation, but that's all we're doing here. So we've got 3 variables. 2 of them have negative exponents. The b has a positive exponent. Leave it. But the a, that a to the negative 2 needs to go to the bottom and become a to the positive 2. The c to the negative 5 would come to the bottom and become c to the positive 5. That's how that works. We got an a, b, a c, and again, we got a negative 7. All right, so what am I trying to teach you here? Yes, be careful. There's a difference between having a negative number and having a negative exponent. Just because here's what you're going to do now. You're thinking, oh, negative numbers mean reciprocate. No, negative exponents mean reciprocate, which means this negative 7, which just is a number hanging out, don't reciprocate it. Leave it up top. The a, leave it up top. It has a positive exponent. Don't mess with it. The c has a positive exponent. Don't mess with it. The only thing that needs to reciprocate here is the b. Put that b to the 11th on the bottom. And that's it. Really, the only thing that changed was the b. Nothing else changed. Third row. Okay, good. So now we're on to the second version of the negative exponent, which is this, right below me, right here, right below. 1 over a to the negative n equals a to the positive n. So this right here, That z is in the denominator with a negative exponent. It needs to reciprocate. Now, I'll be detailed here. If we reciprocate this whole thing, we would have z cubed over 1, but the over 1 is redundant. You can just write z cubed, right? Dividing by 1 doesn't change anything. So that right there would be the answer. The 13 is just meant to distract you. It's not doing anything. Just bring that d to the negative 14 to the top, make it a positive 14. Yeah, that's it. That's all you got to do. All right, here we go. Yes. People mess this one up. I do actually use these notes in the classes that I teach, so I see what students do. Here's the situation. This -7 and this 3 are not connected. They have nothing to do with each other. If there were parentheses around the 3 and the t, then yes, that 3 would also be part of the reciprocating process. But the 3 and the 2 are they're just there. They're just hanging out. They're just there. Don't move the 2 and the 3. It is only the t that has the negative exponent, and that's what needs to reciprocate. So to that t to the -7 comes to the top and becomes t to the +7. Just like that. That's it. This one's really messing with you. All right, so here the 4 and the y are grouped. They are a package deal in parentheses, and that group, that package, has a negative exponent. So that package, the 4y, together needs to reciprocate. Don't move anything else. The 5 stays, and the x squared stays where it's at. The 4y comes to the top, and it becomes a +6. Now, yes, there's technically more we could do with this problem, but for now, all I'm trying to teach is the negative exponent. So you can just stop right there. That's fine. All right, this fourth row right here is combining both properties of negative exponents that we've learned so far. So there's the first one. Basically, if it's up top and it has a negative exponent, it needs to go to the bottom. And the second one was the reciprocal of that. If it's in the bottom and has a negative exponent, it needs to go to the top. So what does this look like? Okay, let's look at the A. The A has a negative exponent. It's in the top. It needs to go to the bottom. So this will be a to the +3. The B has a positive exponent. Leave it where it is. It's in the top. The C has a positive exponent. Leave it where it is. The D has a negative exponent and it's in the bottom, so reciprocate it to the top. D to the +6. And this is the confusion. People think, oh, it has a negative exponent, it needs to go to the bottom. Well, it depends where it is. If it's negative in the top, then it goes to the bottom. But if it starts in the bottom and it's negative, then it goes to the top, right? Either way, that's reciprocation, right? Either way. Same thing. It's A, B, C, D again. This is the same type of problem. The A has a negative exponent. It's in the top. It needs to go to the bottom. The B has a negative exponent. It's in the top. It needs to reciprocate to the bottom. The C has a positive exponent. Leave it in the top. Don't move the positive exponents. The D in the bottom has a negative exponent. It needs to reciprocate. It needs to go up and become positive. The 6 and the 11 are just meant to distract you. They're not going to move. They're just going to stay where they're at. The A has a positive exponent right there, a to the +3. You leave that where it is. The B has a negative exponent. Reciprocate it to the bottom. The C has a negative exponent in the bottom. Put it on the top. Make it positive. The D on the bottom has a negative exponent. Reciprocate it to the top. And that right there, I'm going to center that 11b to the 4th. And that is the answer. Moral of the story, if it has a negative exponent, move it. If it's on the top, move it to the bottom. If it's on the bottom, move it to the top. That is called reciprocation. Same flavor here. The 8 and the 3 are just meant to distract you. Leave them where they're at. That a to the third stays up top. We need to bring the b to the top. We need to bring the c to the top. And we'll leave the d on the bottom. So yes, I did that fast. If it had a negative exponent, I moved it. The b and the c were the only variables that had negative exponents. Those are on the bottom. They are now on the top with positive exponents. That's called reciprocation. And this brings us to the bottom row, which is the third property of the negative exponent, which really is just the first two combined, right? So you'll see here right below me. Actually, I want to pull it up so I can actually write on it here. This is what it is. And what you see on my screen right now on the main screen is actually a little bit longer than what's right below me. Here's the deal. If you have a over b to a negative exponent, you're just going to flip the whole fraction. You're going to reciprocate the whole fraction. So you see right here you have an a over b, but in the next step you have a b over a, and the exponent became positive. It was negative, it became positive. And then a step further that you don't see right below me, but that I am going to do, is that then you can distribute this right here. Right, earlier we were talking about, what do we have earlier? We had, is it power of a product? Yes, we had this property right below me. This last step right here is essentially the power of a quotient. Now, I don't have that explicitly labeled in this lesson, but that's what it is. That's what it is. So we're going to do that. I realize it only makes sense when you actually start to see it. Let's do it. Let's do it. So what I might do here is, because of the negative exponent on the outside, I would reciprocate the whole fraction. So the 2/3 becomes a 3 over 2. And that negative 3 exponent becomes a positive 3. I can then distribute that exponent like I did over a product, but you can also do it over a quotient. That's just fancy word for division. So that would be 3 cubed over 2 cubed. Now, what is 3 cubed? What is 3 times 3 times 3? That is 27. And what is 2 times 2 times 2? That would be 8. So the answer here, this one simplifies completely to a 27 over 8, 27 eighths. Same thing with variables. Hey, the good news about variables is this is going to be one less step than the last problem. But go ahead, reciprocate first. P over Q becomes Q over P, and now you have a positive fifth power. Distribute that 5. You can distribute an exponent over a fraction, a quotient is the proper word there. That would be Q to the 5th over P to the 5th. All right, now we're getting a little fancy here. That -1 is going to reciprocate what's inside. So that's going to be y3 over x squared, y cubed over x squared. And now, now to the +1. And then, yes, I would technically distribute that 1 to the exponents inside. However, 3 times 1 is 3. And 2 times 1 is 2. So really nothing changes here. This is just y cubed over x squared right there. And that, again, that's just the reciprocal. That is the reciprocal of the original question. The original question had an x on top and a y on the bottom, and now it's flipped. Why? Because we had a negative exponent. Here we go. Here we go. This is fun. There's a couple different ways you could do this. You could, if you wanted, right away, distribute this exponent. So I'm going to do it a little bit differently than the last two so you get some perspective here. But how would this work? This would be c to the -4 times -3, d to the 5 times -3. All right. -4 times -3. Right, that's a negative times a negative, gives you a +12. But what about the d? We had a 5 times -3. That is a -15. So actually what I have, my third property below me right now, is not the way we did this problem. We are now in the second negative exponent property situation where we have a variable in the denominator with a negative exponent, meaning it needs to come up with the c. And there's no more fraction anymore because there's nothing in the denominator. The c was already on top. The d just came to the top because it had a negative exponent, and that's the answer. Can I even zoom out to all of those? Let's see. Not really, but here's a look at all of them. I'll scroll slowly. The first two rows was the first box. The second row was the second box. The third row was the second box. The fourth row was a combination, and the fifth row was the last box. But there's a variety of negative exponents. Again, moral of the story is the negative exponent implies reciprocation. That's how you handle that. All right. I'm going to pause and take a restroom break. Okay. We're back. If you're wondering, if you're into this kind of stuff, I'm using OBS Studio to make this, and oh my god, oh my goodness, it's incredible. You no longer have to edit videos. You just record all at once. I just hit the pause button. I'd never done it before. I was a little nervous, but I hit the pause button and then just hit it again, and it looks like we're still going. So, anyways, I am going to take my time through these for those that want the details. If you just want to see the answer, you keep skipping. You can hit that skip arrow, see the problem, then see my highlighted answer. But I will display all the properties used as we work through these. And they'll just get gradually bigger. So we'll call this section practice 2. Why is this? Did I refine these a little bit? Let me think. I don't really know. Let's just see what happens. Simplify these. Final answers must have positive exponents only. That's what the instructions say. Positive exponents only. Okay. So here, the first thing you might do is use this property right here. No, you know what? I'm going to do this a different way. I'm going to use the product of powers properties first. This is the first thing I'm going to do. I'm going to add the exponents, even though one of them is negative. So I would go 7x negative 9 plus 4. And what is negative 9 plus 4? Negative 9 plus 4 is negative 5. All right, we have a negative exponent, and we need to deal with that. And that's going to be this property, the negative exponent property 1. The 7, careful, the 7 is not attached to the negative 5. The 7 itself does not have an exponent. Well, besides 1, it technically has a 1. Meaning, just leave it. It's only the x that needs to reciprocate. This is 7 over x to the 5th power. That's the answer right there. So that's one way you could have done this. Another way you could have done this. Again, I'm trying to show you here that there's multiple different paths. You could have started with this property, which is what I just had up right here. So you have that x with a negative exponent. So you could have started by rewriting this as 7x to the 4th, and then put that x to the negative 9 to the bottom. Well, I made a mistake. What's my mistake? It should be a positive 9 now. If you reciprocate, right, it makes that exponent positive. All right, so now what you would do is use the quotient of powers, because now instead of x times x, you have an x over an x. So this would be 7x to the 4 minus 9. All right, well, 4 minus 9 is negative 5. Oh, look, you're in the same position we were before. The last thing you would do here is apply this negative exponent property for 7 over x to the 5th. So it's up to you which path you take. How about this right here? I would always, almost like a PEMDAS problem, right? P parentheses. I would always try to simplify parentheses first before you start distributing. Yeah, so we could distribute the 5 to everything right now, but why don't we condense what's going on inside? So the first I would use is the product of powers right here. Let's add the exponents on the inside. So this would be 2b 7 plus negative 10, technically. Now, 7 plus negative 10, that means 7 minus 10. 7 minus 10. What is 7 minus 10? 7 minus 10 is negative 3. All right. Now let's distribute. Let's use our power. Is this what I want? This is what I want to use? Yeah, power of a product. We're going to distribute, well, in combination with power of a power. So we got to use power of a power and power of a product at the same time. We're going to distribute the 5 to the negative 3 and the 2. And that gives us 2 to the 5th power. And B, negative 3 times 5 is negative 15. Right there. All right, and now we're going to use the negative exponents. Also, at the same time, I want to evaluate this. What is 2 to the 5th power? We've done that once today already. That is 32. And then now it's going to be b over b to the positive 15. The triple K's again. I was not thinking this is funny. All right. I hope you appreciate the humor. Simplify. Simplify. What's in the parentheses first? This is going to be, we're going to use the product of powers property right here. Now, notice below me in the property, you only see an m plus n. Well, we could have used 3, right? We have 3 here. Not this 3, but I mean we have 3 exponential terms. Just add them all. Negative 13 plus 5 plus 3. You just add them all up in a row like that. And this would be negative 3 plus 5 plus 3. What is that? 8. Negative 5 right there. Yep. Negative 2. All right. Now, I would use power of a product and distribute that exponent. So multiply the exponents, distribute. And this, okay, here's another mistake I see students making. They think, okay, yes, you have to multiply the exponents, but you're not multiplying negative 2 by 3. You don't multiply 3 by negative 2. This becomes 3 to the negative 2nd power. And then k, all right, what is negative 5 times negative 2? That's positive 10 right there. That's positive 10. All right, we have a negative exponent we need to deal with. So that is the property for that. The k has a positive exponent. Leave it. It's the 3 that has a negative. So that 3 to the negative 2nd power is going to become a 3 to the positive in the bottom. And we can actually evaluate that. 3 squared, or 3 times 3 is 9. That's it. There you go. There's my politically incorrect math problem. That's how it's done. That's how it's done. How about this? Okay. What's nice about this problem is there's only one variable. That is y. Right? Have we had a mixture of variables yet? No. So far, all the problems have had one variable. That's nice. We have some 8s too. All right. The first thing I would do here is a combination of product of powers. We're going to use this property where we add the exponents. Right. This is funny. If I point to where I see it, it's right there on my screen, but I know it's below me in the studio right here. So, and then this one, we're going to use a combination of product of powers and quotient of powers. So what would this look like? For the 8s, this would be 5 minus 3. Do not try to figure out 8 to the 5th power, 8 to the 3rd power. We can just subtract the exponents. For the y's, up top we have negative 10 plus 18. But then we're going to subtract that 6 that's in the bottom. So that's what that's going to look like. Hold up. I need more room for this. There we go. So 5 minus 3 on the 8 is 2. And then on the y's, we have negative 10 plus 18. That's 8 minus 6 is 2. So this ends up being 8 squared y squared. Well, 8 squared, we could evaluate that. 8 times 8. Do that. 8 times 8. What is 8 times 8? That is 64. So we have 64y squared. These are just getting bigger, but it's all the same thing. Let's get all the p's together by using product of powers. We're going to add the ones that are on top, and quotient of powers. We'll subtract the ones that are in the bottom. So I'll leave this one displayed. Product of powers. The 11 and the 12 we're not going to mess with yet. But I'm going to write this. I don't remember if the p is going to end up being negative or positive in the exponent, so I'm just going to put it in the middle for now. This will be negative 9 plus 7. Then we have to subtract the 13 that's in the bottom, as well as the negative 10 that's in the bottom. Watch out for that double negative. That's a minus negative 10 squared. Okay. Equals. Let's keep the 11 over 12. I'm not sure what's going to come of the p yet. I have to do this in one step for the sake of room. Negative 9 plus 7 is negative 2. Minus 13 is negative 15. Plus 10 is negative 5. So it did end up being negative. Because it's negative, it needs to go to the bottom. Can you see what I'm writing still? Yeah, we can still see this. So this will be p to the positive 5. All right, I have to execute this in one more step. Let's see if I can zoom out a little bit more. Zoom out a little bit more. There we go. Okay. All right, you're going to square everything in the parentheses now. 11 squared is 121. 12 squared is 144. As far as the p goes, you are multiplying the 5 and the 2 because they're exponents, and that is 10. So notice the difference between what happens here. You square the 11, you square the 12, but you multiply the 5 and the 2. It all depends because 5 is an exponent, 11 and 12 are not. I don't want to see 22 over 24, right? I don't want to see 11 times 2 and 12 times 2. It's 11 squared and 12 squared. Really, the only thing I'm doing here is just making them longer, right? This isn't even... You know what? Let's do this a way we haven't done before, just so you get some variety. The first thing I'm going to use is the third property of the negative exponent, this one right here, where because we have a negative exponent on the outside, we're just going to flip everything that's on the inside. But pay attention. Pay attention here. We're going to flip everything on the inside, but we're not going to change any of it. So the 2 is still negative. The 3 on the A is still negative. The 7 on the A is positive. So all I did was I rewrote the numerator as the denominator without changing a thing. Copy it down. Now I'm going to copy the denominator to the numerator. All this changes is the negative 4 on the outside. It will now be a positive 4. That's all that does. Don't change any negatives on the inside. We reciprocated not because of this negative 3, not because of this negative 6. We reciprocated because of the negative 4. So nothing on the inside changes. All right. What do I want to do next? I essentially want to use product of powers and quotient of powers. So I'm going to add and subtract all the exponents because we have 5 A's here. That's crazy. Who wrote this problem? I'm going to leave it as a 1 over negative 2. And for the A's, we have 8. All right. Plus negative 6 is minus 6. We got to add the 5. Minus negative 3 in the bottom is plus 3, but minus 7 in the bottom. So you might have to think about what just happened. But I'm going to be a little less detailed because we have a limited room. What is all this right here? 8 minus 6 is 2, plus 5 is 7, plus 3 is 10, minus 7 is 3. A to the third power. Let me think that one more time. 8 minus 6 is 2, plus 5 is 7. Yeah. All right. Good. We could rewrite this as a cubed over negative 2 to the fourth power. I'm just rearranging. There's no properties there. And then the last thing we will do is pretty much power of a product, but here it's power of a quotient. Multiply the exponents. 3 times 4 is 12, a to the 12th, over negative 2 to the fourth power is positive 16. Negative 2 times negative 2 times negative 2 times negative 2, that's going to give you a positive 16. It's not negative 2 times 4, right? It's not negative 2 times 4. It's negative 2 to the fourth power. And that's it. All right, here we go. Now we have a mixture of variables. We don't have one variable, we have C's and a D's, and we have 4. 4 is, it's almost like you have 3 variables, but yeah, one of them's a number. First thing I would do here is hit this with Quotient of Powers. Is that what I want to do? No. The first thing I would do is negative exponents. Everything that has a negative exponent, flip it. So the 4s will flip. Now it's a 4 to the 5 on top, a 4 to 3 on the bottom. The C cubed will stay up because it's positive. But you'll notice now you have C to the 8 up top, right? This negative 8 on the bottom needs to be C to the positive 8 on top. The D to the 7th stays up top, and the D to the 12th stays in the bottom right there. Okay. So now we're going to see a mixture of product of powers, where we're going to add the exponents if they're being multiplied, and quotient of powers, or we're going to subtract the exponents if they're being divided. So this would be 4 to the 5 minus 3. So the C's are being multiplied. So right here for the C's, you're going to use product, which means you add the exponents. 3 plus 8. For the D, you subtract the exponents. 7 minus 12. This gives us 4 squared, C to the 11th, and D to the negative 5th. So because of that negative exponent, we need to reciprocate. So negative exponent now. Also, 4 squared is 16. Make that a 16. Keep the C up top. Move the D to the bottom. That's it. That's it right there. Simplify what's going on in the exponents first. Okay. I need to start doing these in less steps. Otherwise, this video is going to be 3 hours long. There's 9 2's in the top. There's 1 2 on the bottom, meaning 1 2 on the bottom will survive. 10 minus 9 is 1. As far as the y's go, 5 minus 6 is negative 1. As far as the x's go, negative 8 plus 7 is also negative 1. So if I combine all my exponents, that's what I'll end up with. The ones that are negative need to reciprocate. So this becomes x to the 1 over 2y to the 1 to the 3rd power. Distribute the 3 on the outside. So we have 1 times 3 is 3. 2 cubed is 8. That needs to be an 8. And then y cubed right there. That's the answer. We got S's and T's. I'll write it like this. As far as the T's go, we have 3 minus 6 plus 7. Now, I get it. If you're not tracking, you're like, wait, I thought we were supposed to add those. Well, 3 plus negative 6 is 3 minus 6. You're like, okay. But I thought we were supposed to, wow, stutter. I thought we were supposed to subtract the negative 7. Yes, minus negative 7 is plus 7. So you see what's happening is because of these negatives, my signs are switching. What about the S's? Up top, we have a negative 2. We need to subtract the 4, and we need to subtract 1. Where did the 1 come from? Right there. That's S to the 1st in the bottom. I put a little blue 1 there for you. Actually, why don't I put it here and here so you can see that those are the same 1. And then there's still a negative 5 on the outside we're going to have to deal with. 3 minus 6 is negative 3 plus 7 is 4. Negative 2 minus 4 minus 1 is negative 7. I might now distribute this negative 5 exponent. That's going to multiply. So right there, that is a power of a product rule mixed with the power of a power, but multiply the exponents here. 4 times negative 5 is negative 20. Negative 7 times negative 5 is 35, positive 35. All right, because of that negative exponent, I'm going to use this space up here. Boom. Because of that negative exponent, we now need to use this property, which means the s has a positive exponent. It will stay on top. It's the t that goes to the bottom. That's the answer right there. All right, different setup here. Really, your only option right here is to use power of a product. Really, it's quotient of a product. No. It's power of a quotient. I know you don't really care about the names, but your first move here would be to multiply all these exponents. I think that would be the smartest thing to do. And you can put all this together. So for the first A, 6 times 5 is negative 30. For the B, 9 times 4, that's 36. For this B down here to the 5th power, B to the 4th to the 5th, that is 20. And then A would be negative 8. All right. Let's go ahead and use our negative exponent. If it's on the top and it's negative, it needs to come to the bottom and vice versa. Whoa, come back to me. Boom. There we go. Okay. Looks like the A's will flip and the B's will stay. Here's another thing you could do. You can rearrange the A's and the B's like this. So the A's right on top of the A and B's right on top of the B. It doesn't matter. The stuff up top is being multiplied and divided by the stuff on the bottom. It doesn't matter the order you write this in. All right. So now we specifically have a quotient of powers. We need to subtract these exponents. So for the A, we have 8 minus 30. For the B, we have 36 minus 20. And that would give us a 8 minus 30 is negative 22. 36 minus 20 is 16. And the last thing we need is the negative exponent. The B has a positive exponent. Leave it up top. The A has a negative exponent. Reciprocate it. It's now on the bottom. What's the difference between this problem and the last problem? Notice how in the last problem you had different variables in each of the parentheses. Here you have the same variables in the parentheses. So here we have x's inside and y's inside, meaning we could do this problem in a different order. I'm going to start this problem by using quotient of powers. How will this look? Let's see, I think I can squeeze it right here. That means right here, I'm going to go 8 minus negative 7. 8 minus negative 7 is 8 plus 7. That means in the first parentheses here, you really have an x to the 15th squared. Right here, this would be negative 1 minus 5. That's negative 6. So this simplifies the y to the negative 6 with a negative 3 on the outside. Can you see all that? No. There's still a negative 3 on the outside right there. Okay. Now I would distribute these exponents. These are two little power of a power examples. This is where you multiply the exponents. So 15 times 2 is 30. Negative 6 times negative 3. Well, that's convenient. That's positive 18, and you're done. Wow. That's it. Very nice. So the first one here has an R and a Q. The second one has 2 R's and the last one has 2 Q's. So here's what's going to happen. With this, I'm going to apply, I'm going to distribute the exponent first. That's what I'm going to do here. I don't have a choice. But here, I could subtract those exponents and I could subtract those exponents. So most of what I'm going to do right now is quotient of powers, but I'm also going to distribute. So what would the next step look like? We would have R to the positive 28, negative 7 times negative 4 is positive 28, over negative 6 times negative 4 is positive 24. Here, 19 minus 15, subtract the exponents, is going to be 4. 9 minus 17 is negative 8. Am I going to have enough room? Let's see. I really don't like seeing other problems. Okay, here we go. We got a little more room now. Okay. Look, I'm going to do this faster as I take my time to draw a perfectly straight line. So this is going to be r to the 28. This right here is going to be r to the negative 8. And because it's negative, I'm going to put it to the bottom and make it a positive 8. This right here is going to be q to the negative 24. And because it's negative, I'm going to put it to the bottom and make it positive. We also have, we also have this other q to the 24. That's crazy. We have, so this is that one. I guess it doesn't really matter. And this is that one. Good. We now need to subtract the r's, which would give us r to the 20th. 28 minus 8 is 20. And then 24 plus 24 is 48. You might have to think about that. All right, that completes practice 2. So here's the first, there's the first 6 right there completed. And again, disclaimer, I make mistakes. There might be something in here that's wrong. That's fine. You know, correct it, figure it out, practice these. Here's the bottom 6. Practice 3. So these are just going to get bigger. That's all we're doing here. We're just getting bigger, making them bigger. Simplify the following. Final answers must have positive exponents only, right? We want final answers. We don't want any negative exponents. All right. Yeah, I remember this one. My students did not enjoy this one. Let's see. I want you to realize something here. Everything in the brackets is being multiplied. Multiplication is commutative, which means the order does not matter. You can rearrange this term by term. So, can we see if I write right here? Can we see that? Yeah, actually, I can put that a little bit more right there. Okay, good. You can do 2 times 5. You can do a to the negative 5 times a squared. B cubed times b to the 7th. C to the negative 4. C to the positive 4. 5 on the outside. That's what this means. Spread out and rearranged. Your A's with your A's, your B's with your B's, and your C's with your C's. Now, because there's only one layer of grouping, the brackets, I'm going to switch to parentheses. Brackets and parentheses are the same thing. They serve the same purpose. But let's bring this down to parentheses. 2 times 5 is 10. Negative 5 plus 2 is negative 3. I'm adding the exponents. So right now, I'm doing product of powers on all the A's, B's, and C's. 3 plus 7 on the B is 10. Negative 4 plus 4 on the C is 0. Ah, we got a little 0 right there. What I might do now is distribute the exponent to everything. Don't forget the 10. Reminder, this is not 10 times 5. This is 10 to the 5th power. Multiply the exponents. Negative 3 times 5 is negative 15. 10 times 5 is 50. 0 times 5 is still 0. Last thing. 10 to the 5th power is a 1 with 5 zeros after it. 5th power will give you 5 zeros. What is that? That's 100,000. Now, good. Let me move this over here because we also have some negative exponents we need to deal with. So we need to deal with negative exponents. We got to do this. The B stays up top because it's positive. That's a 50 on the B. Sorry, I don't know why I just started struggling. The A goes to the bottom and becomes positive. A to the positive 15th. Now, C to the 0, that is the 0th power right there. So that's what we're dealing with right below, right below, 0th power. C to the 0th power is 1. It would be pointless to put a little times 1 right here because that's not going to change anything. So the C functionally goes away. And we can see that from the very beginning because we have a negative 4 and a positive 4. Those are going to cancel. This is the answer. First thing I would do here is I would distribute this -1 to everything in the parentheses that it's attached to. So this is like power of a product. Yeah. Multiply all the exponents. So this would be 3 to the negative first power, x to the -5, y to the +2, z to the +7. All of this is still being cubed. That 3 on the outside. Now I would do it again with this 3. Boom, boom, boom. To everything. Get them all. Get them all. Let's pull this down a little bit. Okay. So now we have 3 to the -3. We have x to the -15. We have y to the +6, z to the 21. So I just multiplied all these exponents. This was a power of a product mixed with power of a power, right? Power of a power, you'd multiply the exponents when you power of a product distribute them. Good. Now we need to jump into the negative exponent. We need negative exponent now. Give myself a little bit more room. Whatever is negative needs to go to the bottom. So the y to the 6 can stay up top. The z to the 21 can stay up top. I'm going to do this in one step. 3 to the -3, that's going to reciprocate and become 3 to the +3. But 3 to the third power, 3 times 3 times 3 is now a 27. But it's in the bottom, not the top, as well as the x to the +15. First thing you could do here is reciprocate everything that's negative. So first thing I'm going to do here is, oh, there it is. I still have it. Negative exponents. That's what I'm going to do. And I'm going to use this one, and I'm going to use this one, right? It just needs to reciprocate. So whichever one, however you see it. The p's will need to switch. The 12 comes up top. The 8 goes to the bottom. The q to the 10 will stay where it's at. The r to the 5 needs to go to the bottom. The q to the -2 comes up top. The s to the 4 stays where it's at. So all that happened there was we moved the ones that were negative. We reciprocated the ones that are negative. Now we are going to use a combination. We're going to use product of powers where we add exponents if they're being multiplied, and quotient of powers where we subtract the exponents if they're being divided. So on the p's, that's being divided. 12 minus 8 is 4. Q's, those are being multiplied, so 10 plus 2 is 12. There's only one r. You can't combine it with anything, and there's only an s. You can't combine that with anything. That's actually it right there. That's it. Whoa. Oh, I've been looking for that option for a long time. All right. I have no idea how I just did that. Here we go. Ooh, nice. What do we want to do? I'm going to distribute exponents first. Sure, why not? That 2 needs to go to everything right there. That would be, that right there is a power of a power. No, just kidding. Power of a product, right there. Okay, that's the first thing. Right below is this right here. And it's also going to be this. I need to multiply. I'm going to distribute that exponent to everything. There we go, right there. Notice how this is on the outside of the parentheses. That's what I'm trying to teach you with this one too. Is that 3 to the -11th is outside the parentheses, which means we're not going to do that. We're not going to distribute the 2 to the -11. Only what's in the parentheses. So what would this look like now? I'm going to move that 3 to the -11 to the bottom. I know that's going to have to happen anyways. Now at top we have m squared n squared. That's this right here. That becomes that right there. And then what do we have now? We have 3 to the -15, m to the +18. I'm multiplying the exponents. And then -7 times -3 is +21. Okay. I think I do anticipate needing a little bit more room here. So let's put that right there. Equals. That 3 to the negative 15 will come up and become a 3 to the positive 15. Actually, I think that's all I'm going to do right now. Yeah, okay, there wasn't, I just moved the one thing right there. All I did was move one thing. But anyways, this looks nice now. This is compact. We're getting closer. All right. I am going to start to do something I haven't done before. And that is, you want to anticipate where variables are going to end up. Or I should say where terms are going to end up. So if I'm looking at the 3's here, I know I have to subtract the exponents. So right now we're doing quotient of powers. This is what we have to do now, subtract the exponents. I'm looking ahead. I'm like, okay, 15 minus 11, that's going to be a positive 4, meaning the 3 will stay up top. But here, if I'm looking at the m's, I would have 2 minus 18, which is negative 16. Or you could do it the other way around and be like, oh, well, there's more m's on the bottom. So the answer is going to have the m on the bottom. 18 minus 2 is 16, but it's on the bottom. Same thing with the n's. I'm like, okay, look, 21 is greater than 2, so there's more n's on the bottom, meaning whatever survives will be left on the bottom. 21 minus 2 is 19. That's it. Last step here, 3 to the 4th power, 3 times 3 times 3 times 3 is 81, M16, N19. Sorry if you think I talk too much. Again, you can just pause this and just skip through it until you see the answers, right? You don't have to sit here and listen to me. But if you want the explanation, I got more. Notice how there's nothing in the parentheses that can be simplified. I mean, sure, we could deal with negative exponents, but let's just wait on that. I would distribute this 3 on the outside. So this is going to be power of a product mixed with power of a quotient. Multiply, power, multiply, multiply, power. Okay. What would this look like? This would be negative 5 to the negative 3rd. X to the 12th. 2 to the negative 3rd. Y to the negative 21. Z to the positive 18. Next, negative exponent. The negative 5 to the negative 3 reciprocates and becomes negative 5 to the positive 3. The 2 to the negative 3 also reciprocates. X will stay where it is. The y needs to come up. The z will stay where it is. Okay, what happened there? Every exponent that was negative reciprocated. Well, the exponent didn't reciprocate, but the term did. All right. Equals. Can I finish this in one more step? Yes. 2 to the 3rd power is 8. Actually, all we have to do is the numbers now. What is negative 5 to the 3rd power? Negative 5 times negative 5 times negative 5 is negative 125. 125. It is negative. But I'm going to put the negative up here with the 8 now. So, again, this 8 is now negative because of that negative right there. I just prefer to have it in the numerator. To me, that looks cleaner. That's the answer. Here we actually can simplify what's in the parentheses first. So this all is going to require quotient of powers. We're going to subtract all these exponents. Watch out for double negatives. That 4 isn't doing anything yet. All right, I have a to the 3rd over a to the negative 1. So that's going to be 3 minus negative 1 or 3 plus 1, which is 4. The b, let's go ahead and put the b on the bottom. That was just a little negative exponent reciprocation. C, I would have negative 2 minus 2, which is negative 4, meaning it needs to go to the bottom and become a positive 4. Three on the outside. All right, now let's distribute that exponent. Sorry, brain fart. I was looking for my black pen here. Here we go, equals. All right, 4 cubed. I'm going to finish this in one more step. This is not 4 times 3. This is 4 to the third power. 4 to the third power is 64. And then a to the 12th, b to the 12th, c to the 12th. Yeah. Oh, and I totally, wow. I just realized I totally ditched this 3 right here. I ignored it completely. So let's squeeze that in. There would be a 3 right there. And 3 to the third power, you need to do that as well. Nope, I want blue. You would do that. Oh my goodness. Give me blue. Give me blue. There we go. Boom. Okay. You would also need to do 3 to the third power. 3 times 3 times 3 is 27. There it is right there. That's it. Let's fix that fraction bar. Good. Oh, okay. So that was practice 3, a little bit longer. There's the first 2 right there. And there's the last 4. There's the other 4. If you find a mistake, leave it in the comments. I guess these numbers aren't exactly labeled, but it's on the practice 3 page right now. Practice 4. Okay. How many problems do I have here? I have 6 more. Let's just do these. Here's the deal. You know what? I'm just going to stop talking. Because if you're here, you understand this to a degree. I'm just gonna solve these. Well, it's not solve. I'm going to simplify these without too much talking. one thing I will say here is that right here, when I multiplied those exponents, I would have q to the negative 14. I went ahead and put that in the bottom. That's why you see a q to the positive 14 in the bottom. So I did that at the same time. So again, in one step, I'm going to distribute all my exponents and move all my negatives. I'm going to try to get that done in a single step. Starting with the m's and the n in the front there. Whoa, 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 what am I doing? 2 to the 5th would stay in the bottom. Okay, so right there, if I multiply those exponents, negative 5 times 5 is negative 25, meaning it needs to reciprocate. So you see a positive 25 up top. Adding the exponents up top. 2 to the 5th is 32. Add all my exponents in the bottom. M's with your M's. N's with your N's. Now subtract. I see. I feel like I made a mistake. No. 12 plus 1, 35. Okay. End of the 5. 32. M squared. Okay. I don't know. I feel a little uneasy about that one. I don't remember that answer when I did this in class. So that one might be wrong. Take a picture of it with PhotoMath, see what it says. Maybe it's right, maybe it's right. I don't know. Okay, here we go. So that right there is 64 a to the 6th. That right there simplifies to that. I multiply the exponents. Okay. Now I'm going to distribute the negative 1 at the bottom. Positive 3. B is going to go up. C is going to go up. Add your B's. Add your C's. Add your A's. Let's simplify what's in parentheses first. C's cancel. 4 to the 3rd power is 64. Multiply the exponents. Ah, there you go. That was it. 4, 5, 9. Cancel. Yeah, good. Okay, here's what's going through my head right now. I know that there's going to be some terms that end up on top and some terms that end up on the bottom. I also see that we're dealing with some numbers right here. I'm just focused on this right now. That part right there. I see a 4/3 to the -2. I just like having numbers first. That's how the answer needs to end up. So let's just start there. Because of the negative exponent, they're going to reciprocate and they're both going to be squared. I'll go ahead and at least write that they'll both be squared right now. All right, now let's go through this. Multiply those exponents. It's a -21. Negative meaning it needs to be a +21 on the bottom. Right here, -9 times -3, that's a +27, so the y can stay up top. 2 times -3 is -6, meaning it goes to the bottom and becomes a +6. How about right here? I can actually simplify those. Okay, I'm going to do all this right here. I'm going to do my x's. That's going to be -5 minus 8 is -13 times -2 is +26. Let me think about that again. I don't want to mess that up. I would subtract -5 minus 8 is -13. -13 times -2, negative times negative positive. Yeah, okay, good. And then, let's see, that's going to be z to the -30, meaning it needs to go to the bottom. That's going to be y to the 8th, but it's already on the bottom. Okay, cool. Three squared is 9. I can combine my y's, y to the 27 over y to the 8. Those are being divided. Just because they're not right on top of each other, it doesn't matter. It's still a y up top, a y on bottom. Use the quotient, subtract the exponents. 27 minus 8. 27 minus 8 is 19. What about the x's? How many x's do we have going on right here? Oh. Right, 26 minus 21 is 5. Four squared is 16. Z, we got to add those z's right there. 6 plus 30, 36. Okay. Let's practice 4. There's the first two. Take a picture of these with PhotoMath. See if they're double check. You know, again, I make mistakes. Can we see all these at once? Let me zoom out a little bit. Here we go. Okay. Practice 5. Okay, these ones are just insane for the sake of itself. But heck, you know, if you want to challenge yourself, if you want to grow, you want to get really good at these, here you go. And I'm not going to do a lot of talking. I'm just doing my A's, now I'm doing my B's. On the B's here, I see those in the top. 4 plus 16 is 20. 20 minus 9 is 11. Okay, now I'm doing my C's here. I have a C right there. So 6. Those are all my C's right there. 2 8s on the bottom. 6 on the top, 16 minus 6, 10. 10 on the bottom. And then I'm looking at all my D's. At all of them. Up top we have 2 plus 12, 14, but there's 15 on the bottom, which means a 1 is going to survive on the bottom. Alright, so the B ended up on the top, but the ACD on the bottom. So again, the way I'm doing these problems in, only 2 steps is I'm distributing and reciprocating everything. I distribute any exponents that need to be, like this 2, right? I need to distribute that 2. I'm going to distribute this 3. I'm also going to distribute this negative 2. And I'm also placing them where they need to go, right? If it's positive, I leave it where it's at. If it's negative, I reciprocate it. So like first, I would do this w cubed squared. That's going to be w to the 6. That's positive. So you leave that up top. Then I'm going to do x to the negative 2 squared. So that's x to the negative 4, meaning it needs to go to the bottom. Then I'm going to do y to the 4th squared. That's y to the 8th. And then this z to the negative 3 just needs to go to the bottom and becomes z to the positive 3. My apologies, I'm very particular about my penmanship. There we go. Okay. Next, I would do this. W to the negative 4th cube. That's W to the negative 12. It's in the bottom, but it's negative, so it goes to the top. X cubed cubed. That's X to the 9th. It's positive. Stay in the bottom. Y to the negative 2nd cube. That's Y to the negative 6, meaning it needs to reciprocate, become Y to the positive 6. And then Z to the 5, 3. 5 times 3 is 15. Right here, negative 1 times negative 2 is positive 2, so we can leave it. Negative 1 times negative 2, that's positive 2, leave it. W to the negative 4, so move it to the top, become positive 4. Alright, there we go. So we'll start by, let's just go alphabetical order. We have 3 W's up top, no W's in the bottom, so just add 6, 12, and 4. 6 plus 12 plus 4 is 22. So we have W to the 22. And then Y, let's see, we have 2 Y's up top. There we go. And a Y on the bottom. Is that all the Y's? Yeah, so 8 plus 6 is 14, minus 2 is 12. So Y to the 12 up top. Alright, X right there, and X right there, and X right there. So those are all being multiplied in the bottom, so 4 plus 9 plus 2, 4 plus 9 plus 2, 13, 15. And then Z's. Z right there, Z right there. Yeah, that's it. 3 plus 15 is 18. Good. This is just being ridiculous for the sake of itself. But hey, if you want to try it, all the power to you. Ooh. Can I do this in the way I've been doing it? Let's see. Goodness. Kind of regret writing this problem. Let's see. X 7, 21. I mean, this right here, z to the 0, that's gone. X to the 0 down here, that's gone. Y7, Y21. Z negative 7, Z positive 21. All right, let's see. Okay, what about our X's? Ah, come on. Please stay highlighted. 8 plus 2 is 10. Plus 21 is 31. Minus 4 is 27. Minus 8 is 19. Oh, 42 in the bottom. Here's 64 and 42. You know, there's no way. Yeah, there's no way I could do that in my head. I'm not going to try. So I got 64. I'm going to add the bottom ones first. 64 plus 21 plus 21. And then I'm going to subtract off the top, which is 16 for 90 in the bottom. So the y ends up in the bottom. All right, z's. All right, up top we have 16 plus 12 plus 21 minus 2 in the bottom. That's 47. That could be cleaner. And then, oh, that's it. It's just x, y's, and z's. I was thinking there was another variable. Okay. All right, good. There must be something. All right, good. Actually, you know what? I want to see if that's correct. I'm gonna grab PhotoMath. I'm gonna grab PhotoMath here. No, I gotta download it, and we're good. All right, that's insane how fast that was. Yes. Okay. Let's see. See if I can handle this. X19, Z40, Z15, Y90. So we got the Z wrong. The Z is supposed to be a 15. Okay, so here's the deal. I'm not going to sit here and redo this whole thing, but just FYI, that right there was supposed to be a 15. So, see if you can go find my mistake. Let me just double check. Did I leave any Z's out in the bottom? I don't think so. Z squared in the bottom. Yeah, I don't know. PhotoMath said that it was supposed to be a 15. All right. One left. Oh, goodness gracious. Why do I do this to myself? You know what? I'm not going to sit here and do all this and get it wrong again. So let's just write down. If you want to pause and try this on your own. But here, let me get you the answer. Cancel. No. Go away. Okay. We couldn't recognize your problem? Oh, weak. They're like, we don't do... Oh, here we go. Okay, look. This whole thing simplifies to a cubed b to the 5th over c squared. You're never, ever going to be in a class that you have to do this much. This is just torture. This is pure torture, right? Okay. Good. I cannot guarantee that these are correct. Let's see. I feel like if you're still here, we're just hanging out at this point. No one's here. if they don't enjoy this. Let's see, did I get this one correct? Yes, that one's good. Whoop, whoop. How about this one? $22, $12, $15, and $18. Yes, we got that one. I want to go back up to this. I remember I was suspicious about this one. N5. No, that was correct. I don't know why. I just don't remember having that in class. But, wow. Okay, we've basically hung out for 2 hours now. It's been a great time. All right, quick recap. Properties of exponents. The first is the 0th power. Anything to the 0th power is 1. We then have product of powers. When you're multiplying exponential expressions with the same base, you add the exponents. Then we have power of a power, which means you multiply the exponents. Power of a product, that's your distributive property of exponents, if you will. Quotient of powers, if you're dividing two exponential expressions with the same base, subtract the exponents. Negative exponent property 1. Negative exponent property 2. Negative exponent property 3. And again, what's cool about exponents is it doesn't matter what order you do the properties in. Most of these problems have several paths to the answer. But anyways, thank you for sticking around. I hope this helped. Hope you learned something. And we will see you in the next one.